In the field of cosmology, an emergency is unfolding, one that has caught the attention of leading scientists around the globe. This isn't a typical crisis of misunderstanding or miscommunication. This is an intellectual emergency, a deep-seated challenge to the very foundations of our understanding of the universe. For the past century, we have held a set of ideas about how the cosmos works, ideas that have shaped everything from our understanding of the origin of the universe to how it evolves and might one day end. But the revolutionary discoveries made possible by the James Webb Space Telescope, JWST, in 2022 and 2023 have cast a shadow of doubt on many of these assumptions. According to Nobel laureate David Gross, this is not just a minor issue or a simple challenge to some scientific theories, it's an emergency that threatens to upend much of what we thought we knew. The discoveries made by JWST have the potential to change the entire landscape of cosmology, raising more questions than answers and forcing scientists to reconsider even the most fundamental aspects of our theories about the universe. This emergency began in earnest in mid-2022, with the release of the first images from the James Webb Space Telescope. These stunning, high-resolution images, showing galaxies and stars that are billions of light-years away, provided scientists with unprecedented glimpses of the universe as it existed in its infancy. At the same time, the discoveries that followed began to reveal a universe far more complicated and mysterious than we had imagined. Perhaps the most shocking discovery was the identification of galaxies that existed just 200 to 300 million years after the Big Bang. Given that the universe is 13.8 billion years old, the idea that galaxies could have formed so quickly after the Big Bang was not only unexpected, but it also cast serious doubt on some of our most well-established cosmological models. These ancient galaxies were not just surprising in their existence, they were also remarkably advanced. It was previously believed that galaxies took billions of years to form and evolve into the complex structures we observe today. But the galaxies spotted by the JWST seemed fully formed, brimming with stars and intricate structures, much earlier than we had thought possible. According to astronomers, the fact that these galaxies were shining so brightly in the universe's dark ages, a time when only a few first-generation stars had begun to form, suggested that something very unusual was happening. The implications were profound. Perhaps our understanding of how galaxies form, and when they form, needed a fundamental rethinking. As if that discovery weren't enough, the JWST also revealed evidence of supermassive black holes existing when the universe was still very young, just a few 100 million years after the Big Bang. These black holes were not just small, early-stage black holes, they were enormous, much larger than what current theories predict could have existed at such an early time. This new evidence pointed to the possibility that supermassive black holes were not only more common than we thought, but that they also formed much faster than we believed possible. And yet, these revelations are just the tip of the iceberg. As more data is gathered, scientists are finding themselves facing even more serious questions, ones that could force them to rethink the very basics of cosmology and astrophysics. David Gross has expressed his concern that the entire framework of modern cosmology is under threat. He points out that scientists are not facing a mere theoretical problem. What's happening now is much more profound. We might be witnessing the unraveling of a scientific paradigm that has served as the foundation for our understanding of the universe for nearly a century. The implications of these discoveries could be staggering. If these new findings are accurate, it's possible that everything we thought we knew about the beginning of the universe, the Big Bang theory, and the subsequent development of galaxies, stars, and black holes might need to be completely rewritten. Scientists could be forced to confront the uncomfortable reality that some of the most basic assumptions about the universe were wrong all along. One of the biggest questions that these new discoveries raise is whether we have been wrong about the Big Bang itself. The Big Bang theory has been the cornerstone of modern cosmology since it was first proposed by Belgian physicist Georges Lemaitre in the 1930s. It suggests that the universe began as a singularity, a point of infinite density and temperature, around 13.8 billion years ago. From this point of origin, the universe began to expand, cooling and evolving over billions of years into the vast and complex cosmos we observe today. For decades, this model has been the basis of much of our understanding of the universe's history and its future trajectory. But if these new discoveries are correct, if galaxies and supermassive black holes were able to form much earlier than previously thought, then the Big Bang Theory may no longer be a reliable explanation for the origins of the universe. There is even the possibility that the universe didn't begin with a singularity at all. This is an incredibly radical idea, one that challenges the very core of our scientific understanding. If the Big Bang Theory is proven to be wrong, scientists will have to search for entirely new explanations for the origin of the universe, explanations that could be very different from anything we've considered so far. Perhaps one of the most striking implications of these discoveries is the potential collapse of the Hubble constant, a key observation that has shaped our understanding of the expanding universe. The Hubble constant is based on the observation that galaxies are moving away from us at speeds that are proportional to their distance. This relationship was first discovered by American astronomer Edwin Hubble in the 1920s, and it has been a cornerstone of modern cosmology ever since. Hubble's observations led to the conclusion that the universe is expanding, a theory that was later confirmed by the discovery of cosmic microwave background radiation and other observations. But recent measurements of the Hubble constant have shown discrepancies. The value of the constant seems to vary depending on the method used to measure it. Some measurements suggest that the expansion of the universe is accelerating faster than predicted, while others point to a slower expansion. This discrepancy, known as the Hubble tension, has become one of the biggest unsolved mysteries in cosmology. If the Hubble constant is wrong, it could mean that our entire understanding of the universe's expansion is flawed. This, in turn, would have far-reaching implications for everything from our understanding of dark matter and dark energy to the future of the universe itself. And this leads us to another of the big questions raised by the new discoveries, the nature of dark matter and dark energy. For nearly a century, scientists have relied on the concepts of dark matter and dark energy to explain a variety of phenomena in the universe. Dark matter is thought to be responsible for the gravitational pull that holds galaxies and clusters of galaxies together, while dark energy is believed to be responsible for the accelerated expansion of the universe. But despite their fundamental importance in modern cosmology, both dark matter and dark energy remain mysterious and largely undetectable. We have never directly observed dark matter or dark energy. They are inferred from their effects on visible matter and the large-scale structure of the universe. Recent findings, however, have cast doubt on the existence of both dark matter and dark energy. There are now signs that the current models of the universe, which rely heavily on these concepts, may be incomplete or even entirely incorrect. If dark matter and dark energy don't exist, then we would need to come up with new explanations for the observations they were meant to explain. Could there be another, as yet undiscovered form of matter or energy that is responsible for these effects? Or are our models of gravity and the large-scale structure of the universe in need of a fundamental revision? As of now, scientists don't have all the answers. However, one thing is clear: the discoveries made by the James Webb Space Telescope have thrown open the door to a new era in cosmology, one in which old assumptions are being tested and new ideas are taking shape. The scientific community is actively searching for new explanations, new theories that can account for the strange and puzzling observations we're making about the universe. Some researchers are revisiting old ideas, such as the possibility of a cyclic universe, one in which the cosmos goes through infinite cycles of expansion and contraction. Others are exploring alternative models of gravity, or theories that propose the existence of modified or alternative forms of dark matter and dark energy. As these new ideas gain traction, more and more discoveries are being made. In spring 2023, JWST provided another stunning image, a detailed view of the Pandora galaxy cluster, showing a huge and mysterious structure behind it. This structure is so large that it challenges our current understanding of the early universe. It's far too massive and too old to fit within the models we have used to explain the formation of the cosmos. And this is just one example of the many unexpected discoveries being made by JWST and other space telescopes. The ongoing research from missions like JWST, the Euclid Space Telescope, and the upcoming Nancy Grace Roman Space Telescope promise to continue providing data that could lead to even more unexpected revelations. As these missions gather more data, it's likely that we will begin to piece together a new picture of the universe, one that might bear little resemblance to the universe we thought we knew. But for now, the scientific community remains in the midst of an intellectual emergency, with more questions than answers, and an uncertain future ahead. The discoveries we've made so far have already forced us to reconsider the foundations of our cosmological theories. And as more evidence emerges, it's clear that the universe is more complex, more mysterious, and more wondrous than we ever imagined. Whether this is the beginning of a new era of cosmology, one that will lead to a complete overhaul of our theories, or simply a bump in the road on the way to greater understanding, is still unclear. What is certain is that we are living through a remarkable time in the history of science, and the discoveries of the coming years will continue to shape our understanding of the cosmos in ways we can hardly predict. We are only at the beginning of this new chapter, and the universe is ready to reveal its deepest secrets.